Hello everyone, welcome to another lecture. Today we will talk about one specific element of the microeconomic environment that has been kind of important throughout the whole course that we had together, but we kept this element somehow in the background. So even though it is fundamental for the open macro model mm, to say something about international trade, we didn't elaborate a lot on why trade is important and what are the benefits of trade. So today we will talk about this a bit. So the plan for today is that we start with Ricardian trade models and comparative advantage. Then we will say something about specific factors model. Then the model of Heckscher and Olin, the model of Krugman, which includes economies of scale and love of variety, and we will finish up with something that is very, let's say, up to date, very state of the art, new models of comparative advantage, including the model of Eaton and Kortum of 2002. But to start with, let us start first with the, let's say, the fundamental things in the trade theory, that is the comparative advantage. But before that, one slide of, let's say, explanation or motivation why this particular lecture is a part of macro free course at the undergraduate level. As you know, there is one more course on international economics, I think in the next semester, and I really advise you to select this particular course. On the one hand, it's given by a very nice couple of professors from the university. On the other hand, it will it will extend a lot all the things that we will be talking about today at this lecture. That is the motives for international trade and also international migration, which is, let's say, the thing that I'm interested in personally. And mm, yeah, but why there is a lecture of about international trade in this course? Well, it's because trade has been treated very um, in a very poor way during the course in the models that we described. We simply assumed that exports is exogenous or is equal to imports of the foreign country. If you remember this two-country model that we analyzed at some point, and imports in a particular country is a simple linear function of the output or income. And we said that the higher the income of the people living in the country, the higher the demand for foreign goods. And it was all. And it was everything that we told regarding international trade. And this is not sufficient. And this is not realistic as well. Why? Because there are different motives why people and countries trade, and this is the main subject of this lecture today. So let's jump into it. Why countries trade? What are the main motives for international trade and exchange of goods? And of course, I don't want to invent here once again the wheel, which is something that is not necessary doing. I just want to reconfirm your intuitions right now in this lecture and give you some modeling experience on how to formalize those intuitions that you have out there. So first intuition, why countries trade? Well, countries trade because they are different. Different countries have different allocation in production factors, in specific resources. More or less, different goods require different technologies of production, and some economies are better in producing particular goods. For example, I don't know, German economy is relatively better in producing cars than, let's say, the economy of New Zealand, due to historical foundations, and due to the fact that, well, German cars are considered as the best in the world. So this is one source of why it is common all over the world that economies do trade. Secondly, trade generates the benefits of economies of scale, and I hope that this notion of economies of scale is familiar. You are familiar with this notion uh, from your microeconomic class, and it's simply that the larger the market for selling the particular goods, the higher the gains for the firms of selling those goods. And this is true mostly when there are fixed costs of production. And this is what we are going to formalize in one of the models later on. But here it's maybe sufficient to only ask a very naive question. Is it efficient that each and every country produces their own jets, like you know, planes, aeroplanes? And the answer to this question is of course not, because the demand for such aeroplanes is not super big. But the fixed cost of installing the production line of jets in each and every country or each and every region of every country would be enormous, and this would not be efficient. And this is exactly the story of economies of scale. And there is also a third element of this general motivation why countries trade, is that people like to consume diversified baskets of goods. That is why people have relatively different preferences, and this is very okay that we differ among each other in terms of what we like to eat, what we like to listen to, what we like to watch. Therefore, we generate demand for different types of goods. And this differential demand for different types of goods is also a motivation for international trade. And I will give you some, let's say, modeling or mathematical arguments for this later on at the end of the lecture. But for now, it is important for us to remember there are three main motives for international trade: differences in countries' technology of production and resources, economies of scale, and differences in consumer preferences. Okay, so having this initial intuition, hopefully it reconfirms your intuition about why countries trade, we are now ready to jump into some models, into some formal descriptions of what are the, first of all, motives for trade, and but secondly, what are the economic consequences of international trade? Is it economically reasonable to have international trade across economies? I'll give you some arguments in this lecture with some models, okay? So let's start with the first one. The first model that we want to discuss today is the Ricardian trade model, which originates from early 19th century, and the creator of this model is David Ricardo, one of the famous classical economists. The principle of this Ricardian trade model is the concept of comparative advantage. But before giving you the formal definition of comparative advantage, let us first consider a very simple example. Let us define something which we can call the opportunity cost of production. So normally, let's assume we have two countries, let's say the United States and Colombia, and there are two goods that each of the countries can produce, either computers or bananas. Two very different goods. One we can say capital intensive, one we can say labor intensive in some meaning. Okay, so assume that the United States can produce 100,000 computers in a particular moment of time, or 10 million bananas in the same moment of time, and the United States can allocate resources between those two types of goods by producing any linear combination of those goods. So it can be, I know, 50,000 computers and 5 million bananas. It can be 80,000 computers and 2 million bananas. It depends on the relative allocation of resources. But here for the moment we will simply diverge from the, let's say, describing economically the process of production by simply assuming that this is the production frontier, that the United States can produce either those two numbers of final goods and any combination, any linear combination of those two goods. On the other hand, we have the second country, and there in this country you also have some production possibility frontier. Either in Colombia you can produce 20,000 computers or 10 million bananas. Okay. So two important things are striking in the first place here. First of all, note that United States is more productive in producing computers, or has resources that can produce more computers, but the same number of bananas. Okay, so in fact, the United States is dominating Colombia in terms of production possibility or the production resources or the production factors. Yeah? So in the US, you can produce more than in Colombia in general. Secondly, note that the United States is relatively more productive in terms of computers than in terms of producing computers than in terms of producing bananas, and vice versa for Colombia. How to formalize this? Well, let's try to define this opportunity cost of production. So for each computer that can be produced in the US, the opportunity cost of producing this one computer is 100 bananas. It's simply the division of the total number of bananas that can be produced with the resources in the United States and the total number of computers that can be produced in the United States using the same all the same resources. So this is a kind of substitution between production of those two goods. So for one computer, you can produce 100 bananas in the US. But for Colombia, for one computer, you can produce as much as 500 bananas, right? What does it mean? It means that the US is relatively more productive in terms of producing computers in comparison to producing bananas, okay, than Colombia is. Because to produce one computer in Colombia, it costs more in terms of bananas, so the opportunity cost of producing one computer in Colombia is way higher, 5 times higher in Colombia than in the US. And vice versa, we can express the cost of producing one banana in the US in the units of computers and one unit of banana in terms of computers in Colombia. And this is, of course, the reciprocal of what we had before. So now the question is, what is globally efficient in this two-country economy? What I mean by this is what allocation of production is efficient so that you maximize the total number of produced computers and bananas in this two-country economy. So in the US and Colombia, zusammen, like together, okay? Some constraints here. First of all, both goods have to be produced. So it's not that, both countries produce bananas and we are done. No, each of the two goods have to be produced on the market, both computers and bananas. Then, well, all the resources have to be used in both countries, and this is a standard efficiency assumption. You know it from your macro class. If you have a certain supply of resources, the efficient thing is to use all of the resources that you have in the country. So what is globally efficient? Is it efficient that US produces 10 million bananas and Colombia produces 20,000 computers? So think of it for a second and give me the answer. Is it globally efficient? Of course, no. Why? Well, because the opportunity cost of producing one computer in Colombia is relatively high in terms of bananas. So for producing one computer in Colombia, you can produce as much as 500 bananas. Fair enough. While in the US, it's more efficient to produce computers because the relative cost or the opportunity cost of production of one computer is only 100 bananas. And vice versa for bananas. The opportunity cost of producing one banana in the United States is 1/100 of computer, while in Colombia is as little as 1/500 computer. So the efficient thing here is to produce bananas in Colombia with 10 million, all the resources going into the banana sector, while the US produces only the computer good or the technologically advanced good, which means that the total supply of goods produced is 100,000 computers and 10 million bananas in total. What is important is that what is efficient here is that both countries are specializing in the production. Remember that we could assume that each and every country produces every possible linear combination of those two goods, all right? The same for Colombia. This is still not efficient. What is efficient is that both countries totally specialize in the goods, all right? Which means that ex ante, if you don't have international trade, what you have in the United States is only 100,000 computers and 0 bananas. What you have in Colombia available for the consumers is 10 million bananas and 0 computers. So of course, what has to be done in this global economy is the international trade between both countries in terms of both goods, all right? And this is exactly what are the gains from trade, what would give you the gains from trade in the Ricardian trade model. So to sum up, we had two countries with two different technologies of production. So the US was more the technology of production of computers was more efficient in the US than in Colombia, while in terms of absolute efficiency, in terms of relative efficiency, it was more efficient to produce a computer in the United States and more efficient to produce a banana in Colombia. And this is exactly the concept of comparative advantage. That is the fact that a country is relatively more productive in producing a particular good than the other country. And in this way, we smoothly came into the formal definition of comparative advantage. So what the notion of comparative advantage tells us is that the opportunity cost of producing a particular good is lower in terms of another good than in the other country. And this is exactly what we saw here. So the opportunity cost of producing one computer was the lowest in the United States. Opportunity cost expressed in the units of bananas, okay, was lower in the US than in Colombia, while the opportunity cost of producing one banana expressed in the units of computers was the lowest in Colombia. And this simply means that Colombia is relatively more productive in bananas and the US is relatively more productive in computers. And the Ricardian model, as I mentioned, predicts that the efficient allocation of production process is when both countries specialize in the good in which the country has comparative advantage, and then the goods are traded between countries. All right, and then we will show it just in a couple of minutes with a particular form of particular exercise. Trade between two economies can benefit both countries if each country exports a good in which it has comparative advantage. Now, we will see it in a couple of minutes. I hope that you will understand it better when we just simply make some simple calculations. For the moment, what is important is to remember that the principle of comparative advantage or trade according to comparative advantage is that countries export those goods in which they are relatively more productive. That's the whole idea of this concept of comparative advantage. And you can think of it, well, this is super simple and easy. It is simple, but it has very deep meaning in terms of economics, not only international trade, also labor markets. So the new state-of-the-art models of labor markets are also referring to this idea of comparative advantage, being relatively more productive in a particular occupation than in another occupation. And this is the same story here with international trade. Being active in the sector, so the countries being active in the sector in which they are relatively more productive comparing to another sector, vice versa, another country. Okay. So before giving you a computative example about the principle of comparative advantage, let us first discuss what the Ricardian trade model does not say. What are the myths or mistakes in terms of interpreting the outcomes of this model? And the first myth you can find in media or in some opinions that are expressed by some pseudo experts is that free trade is beneficial only if country is strong enough to stand up foreign competition. What does it mean? Well, it means that according to this particular opinion, trade is good only for the rich and developed countries. If you are a poor country, poor African country, you will never ever gain from international trade that is motivated through comparative advantage. And this statement is absolutely not true, because as we saw before, Colombia, being less productive in computers and as productive as the US in terms of bananas, but we could, infinitesimally decrease the productivity of Colombia in terms of bananas. Well, Colombia will still gain from international trade due to the fact that it focuses on producing the goods in which it has comparative advantage. So here, what is the problem with this particular opinion is that people tend to mix up comparative advantage with absolute advantage. Absolute advantage meaning that the country has direct technological advantage in terms of producing a particular good versus all the other goods. This means that the country is more productive in producing this good in absolute terms. And this is what we saw in the previous slides here in terms of the US. So the United States the United States were absolutely more productive in terms of producing computers than Colombia. So it had absolute advantage in producing computers. But it's not enough for having gains from trade because, well, there was no absolute advantage in terms of producing bananas by Colombia, and still it is more efficient to produce bananas by the Colombian economy. Okay, so this is important so that you don't mix up the absolute advantage with comparative advantage, comparing absolute differences in productivity versus relative differences in productivity. And this is super important that you differentiate between those two things. Okay, we are talking here about the relative differences in productivity in the Ricardian trade model. All right. Second myth. The second thing is that foreign people tend to believe that foreign competition is unfair and hurts other countries as long as this competition is based on low wages. The problem with this statement is that it misses the point. It simply doesn't go into the roots of why comparative advantage is profitable for countries. It simply says that trade in general is bad for poor countries. But this is not true. We have in the history of macroeconomics, we have very many examples of countries which were initially very, very poor. They opened up to trade and they managed to converge in terms of productivity and wages across with the countries which were highly developed. Examples? Yes, please. Japan, all the Asian tigers like Korea, Thailand, Taiwan, and nowadays China, of course, is one of the best examples, which tells you that foreign competition is actually good also for the countries in which the initial wages are rather low. Those countries, thanks to international trade, will be able to converge in terms of productivity over time. Okay. And the third myth related to those concepts of comparative advantage is that trade exploits the country and makes it worse off if trade if the workers of this country receive lower wages than workers in other nations. So this statement is somehow related to the previous one, but once again, it makes a point that countries with lower wages are active on the international goods market only due to the fact that the workers are to some extent exploited by getting lower wages. But now let's think of the situation in a different of this situation in a different way. So assume that there is no international trade at all, and there is still this Chinese economy in which you have those low labor costs production plants. So what happens in the world in China? What happens in the world in which there is no international trade? Well, still there is no trade. This means that sales of those firms are lower, and the wages of those firms are that are given by those firms are still lower. Which means that not having international trade in this particular context makes the individuals worse off. And what trade allows you to do is to focus on those sectors in which you have comparative advantage, in which you are relatively more productive, right? But those productivity differences will exist whether or not international trade is switched on or switched off, right? So a better explanation maybe of those myths related to the Ricardian trade model and the concept of a comparative advantage, you will find them in one of the materials I will submit here on Moodle, which is the chapter from one of the undergrad international trade books. which simply tells you some more detailed information about the concept of a comparative advantage, one factor Ricardian model, and trade in this model, with some nice stories, including stories from sports, including some other the case study of no trade counterfactual, let's say. And here you have those misconceptions which I discussed a bit, and this here you can stop. Okay, this is not relevant. So the comparative advantage model with many goods, this you can skip. This is not relevant. So if you have time and if you are interested in those things and you want to prepare well for the exam, these are few pages that you should look at and you should read to have a better understanding of the concept of comparative advantage. Okay, but of course, Ricardian trade model is not an ideal model, and this paradigm is, even though it's working in some circumstances, in general, it's not um, as useful, let's say, as it could be when we consider the changing structure of macroeconomies. So there is also a criticism of this Ricardian trade model. So first of all, the model works well only in the static environment when the economies, the technologies do not change, relative prices of goods do not change, and the endowments of factors of production do not change. Okay, and we know that this is not true in the medium and the long run. All of those things will change. That is why sticking with the comparative advantage model of trade is something that might be problematic. Secondly, countries, especially the poor ones, strive to change their structure of production. So let's once again think about the consequences of the comparative advantage trade model. What are the predictions of this model? So if you are a high-tech economy, a country with very advanced technology in terms of producing advanced goods, like the US, Japan, or Germany, you should specialize in producing those particular goods. What about the poor countries? Well, the poor countries have to specialize in producing those goods in which they have comparative advantage. In what goods have poor countries a comparative advantage? Well, in the simplest possible goods, those goods which are very low in the quality ladder, very low in the supply chain of global connections in terms of international trade. And the Ricardian trade model will tell you, since this is a static model, so the Ricardian trade model will tell you that this is the equilibrium situation, and this is how it should stay forever, which is problematic because those poor countries are actually trying to use their current comparative advantage to invest in new technologies and upgrade their upstream potential in terms of the quality of products that they are producing. And this is not present in the static Ricardian model. All right, the developed countries produce advanced products while the developing world exports simple goods, and there is no room for convergence in production technology when poor countries expose themselves to free trade. And this is, of course, a problem of every static model, that you are simply analyzing a snapshot of the economy. But in general, this Ricardian trade model will tell you that there is a permanent divergence in terms of product quality of the developed world and product quality of the developing world. There is no convergence in terms of the technology, as it is a standard static environment. Okay. However, even though this is not a dynamic model, we will have some dynamic models later on. Even though the concept of comparative advantage is fundamental in trade theory, in labor market theory, and in economics in general, and this is one of the most important things that you should know after finishing your undergrad studies, right? Comparative advantage, the principle of comparative advantage, and the efficiency that it generates, efficiency in allocation of production, in assignment of people to different occupations. This is all driven by comparative advantage. Okay, so now if still it's the notion of comparative advantage is not clear, let us do a very simple numerical example. So here I have a very simple problem in which we have two Ricardian economies and in which we have to analyze two scenarios, the no trade scenario and the opening to trade scenario. And we will try to evaluate what are the gains from international trade when countries trade, but they trade goods which they produce according to the comparative advantage they have in producing those goods. All right, so let's try to solve this problem right now quite fast. So here I have a standard Word document produced for you with the problem. So you are free to pause the video whenever you want, just to to digest what the problem is asking, and we will immediately jump into solving the problem. All right, so A, draw the production possibility frontiers for each of these countries. Okay, so what we have here in the question, in the problem. So we have two countries, country A and country B. In both countries, labor is the only factor of production. And both countries have different endowment of labor, different supply of labor available. So the country A has 60 units of labor, country B is larger and has 120 units. Then there are two different goods in our economy. There is good X and good Y. And here you can see what are the technologies of producing those two types of goods in the two countries that we analyze. To put it simply, this is per unit labor requirement for producing 1 unit of this particular good. So to produce 1 unit of good X in country A, you need 1 unit of labor. To produce 1 unit of good Y in country A, you need 2 units of labor. The same for good X in country B, and good Y in country B is produced using 3 units of labor. So this is the environment that we are analyzing. And in this environment, we have to draw the production possibility frontiers for each of these countries. What is this? Well, I hope that the production possibility frontier, the notion, is you know it from your microeconomics class, and it's simply a surface that will tell us which combinations of goods X and Y can be produced in both economies. All right, so let's try to draw this production possibility frontier for both countries. So here we will have good X, good Y, maybe in black. Okay, and we have the quantity of good X, all right, from 0 to infinity. So in the first country, what we know is that the maximal amount of good X that country 1 can produce is 60. Fair enough. So we can put it on our in our graph. So let's say this is 60, and this is exactly this level. All right. On the other hand, if all the resources in country A go into production of good Y, the country can produce 30 units of good Y, which is simply the total labor endowment divided by per unit labor requirement. Okay, so 30 units of goods 2, this is the maximum that can be produced in country A. And this gives us a very simple production possibility frontier. Note that in the simplest Ricardian model, the technology of production is linear in labor. All right, what does it mean? Well, it means that this production possibility frontier, which we are gonna draw right now, is a simple straight line. So you can produce all the combinations of those two numbers, which are the combinations of good X and good Y that you can produce in country A, right? And let's put that this is country A. Fair enough. So the same we can do for the second country, for country B. So in country B, you see that the maximal amount of goods X that can be produced in country B is also 60 units, which is this point here, while the maximum number of units of good Y that can be produced in country B is exactly 40 units, which is 120 over 3, which we can say is somewhere here. Okay, which means that the production possibility frontier for the second country, let's put it in red, okay, is somewhere here. Okay, and this is country B. Fair enough. So we have the we are too fast. So we have the first part solved. Now the part B. Calculate the autarky relative prices of good X in both countries. We can do it for both countries, in fact. All right. So what we are asked here is what is the ratio of prices of both goods? So the ratio of prices Px over Py. Of course, we don't have explicitly any pricing system in this economy. This has nothing to do with the medium-term model that we analyzed in the previous lectures. The price that we can expect that will emerge in this very simple economy will be simply proportional to the costs that are needed to produce each and every good. So in country A, the price of good X is simply 1 over 60 because the cost of producing this particular good is 1 over 60. So one requirement of 1 unit per producing 60 units of total good. Okay. When it comes to the price of the Y good in country A, well, this would be 2 over 60, which we can simplify to 1 over 30. And the ratio of prices, as you automatically see, will be 1 over 2. What is the ratio of prices in country B? As in the same way as we did before, it would be 1 over 60 divided by 3 over 100, which is 1 over 40. All right, and this would be 2 over 3. So you see the relative prices of those goods are not constant across countries, and this will be fundamental in terms of determining the trade patterns in the standard Ricardian model. So now we can also express the prices of good Y in the units of good X, and we of course know that this will be the reciprocal of what we computed before. So it will be 2 for country A, and it would be 3 over 2 in country B. All right, this would be useful later on in our computations. All right. C. A fundamental question: which country has an absolute advantage in good X? Which country has an absolute advantage in good Y? Then, which country has a comparative advantage in good X, and which country has a comparative advantage in good Y? How to decide which country has particular type of advantage? So let's focus first of all on absolute advantage. When it comes to good X, to say which country has a comparative advantage, we simply compare the technologies that are available in both countries. So in country A, to produce 1 unit of good X, you need 1 unit of labor, while in country B, you need 2 units of labor. So absolute advantage is on the side of country A. It's cheaper to produce 1 unit of good X in country A. Therefore, the absolute advantage in good X is country A. What about good Y? Well, the same story. It's absolutely less expensive to produce 1 unit of good Y in country A than it is in country B. We simply compare those two numbers. So absolute advantage in terms of good Y is also in country A. So you see that country A is absolutely more efficient in producing both goods. All right, which gives you, an idea if you compare the United States to, let's say, I don't know, Poland. Okay, well, the United States is way more productive in producing almost every good you can imagine than Poland. Maybe in terms of producing good video games. I guess guys from my country are quite good in this. Anyway, so you see the point. We have one country that is more efficient in producing both types of goods than the other country. Okay, but what about the comparative advantage? So how to say which country has a comparative advantage in producing good X? Well, producing the absolute technologies is not useful right now, because what we are asking now is what is the which country is relatively more producing, and which country is relatively more productive in terms of producing good X relative to producing good Y. To put it in a different way, which country has a relatively lower opportunity cost of producing good X comparing to good Y? To answer this question, we simply have to compare the relative technologies, which we did with those relative prices in the beginning. So producing 1 unit of good X is in the first country, all right, is equivalent to producing half a unit of good Y in the A country. All right, so the relative productivities or the relative prices, in our case, it's the same because we don't have a more advanced pricing system. The relative productivities in country A is 1/2, while the relative productivity of producing good X in country B relative to producing good Y in country B is 2/3, as we computed. So which country has a comparative advantage in producing good X? Well, the one in which the relative productivity of producing good X is lower than in the other country. And of course, 1/2 is lower than 2/3, which means that the comparative advantage in producing good X is on the side of country A. All right, so now the last question. Which country has a comparative advantage in terms of producing good Y? Well, here we need to have the relative, we need to compute the opportunity cost of producing good Y in both countries in terms of good X. And this is what we did here by computing the relative productivities or relative technological parameters in both countries. So producing 1 unit of good Y is equivalent to producing 2 units of good X. So this is the opportunity cost of producing 1 unit of good Y in country A. While producing 1 unit of good Y in country B is equivalent to producing 1.5 units of good X in country B, and this is exactly this number over here, which means that comparative advantage in terms of good Y is on the side of country B. All right, so in country B, it is relatively less expensive to produce good Y when we express the cost of production of good Y in terms of good X, all right, in terms of the units of good X. Fair enough. So now the answer to question is, it's still not the moment to answer the question, but still we know which countries have absolute advantage, and even though country A has an absolute advantage in producing both goods, it has comparative advantage only in producing good X, while country B has a comparative advantage in producing good Y. Okay, so now D. Compute the autarky wages. Which country's workers are better off in autarky? So first of all, we will assume there is no international trade and both countries are separated. So of course we cannot compute exactly the wages that are in the economy because we don't have the labor market, we don't have the production function. The only thing that we can compute is simply compute normalized wages expressed in units of goods. So we can compute, let's say that wages in both countries are normalized to 1, and in country A, we can compute wages expressed in the units of good X. All right, and this would be equal to the 1 unit of wage normalization divided by 1 unit of productivity that 1 unit of labor produces, okay? So 1 unit of good X that is produced with 1 unit of labor, which means that the the real wage in country A expressed in the units of good X is equal to 1, while the real wage in country A expressed in the units of good Y will be equal to the, let's say, normalized nominal wage divided by the units of good Y that can be produced with 1 unit of labor. Having 1 unit of labor, you can produce half of the unit of good Y, so that the price of good Y is equal to 2 when it comes to expressing this price of this good in terms of units of labor. And this gives us exactly the real wage in country A expressed in the units of good Y. In country B, we compute exactly the same things. Let me just copy this here. But we have different numbers. So the relative wage, so the real wage in country B expressed in the units of good X, it will be 1/2. So with 1 unit of labor, you can produce half a unit of good X, okay? Which means that the price of good X is equal to 2 units of labor, while you, as a worker working on producing good X, you are remunerated with 1 unit of wage, which is a remuneration for 1 unit of labor. Okay, so we have 1/2, which is 0.5. Fantastic. And the same thing we do for the last goods in the second country, which would be 1/3, the same explanation as before, which is 1/3, right? Yeah, sure, 0.33, let's say. So to answer the question, which countries' workers are better off in autarky? Well, of course, workers that are living in country A are better off in autarky comparing to the workers that are living in country B. Why? Because real wages expressed in terms of both goods are higher in the first country than they are in the second country. So we compare the real wage in country A expressed in units of good X. Of course, the first number is larger than the second, and then the same thing we do for good Y. Okay, so those guys are better off in autarky. So now, last part of the solution. Assume a free trade with an equilibrium price of relative price of good X and good Y to 0.6. Calculate new wages. Which workers are better off, worse off, and the same? So now we are going to introduce international trade in this system. But as you remember, in the Ricardian trade model, you have to decide which country will produce which good. And this decision is fundamentally related to our analysis of comparative advantage of countries. So country A should specialize in good X, in which it has comparative advantage, and country B should specialize in good Y, in which it has a comparative advantage. So we will have that country A will specialize in X, and country B will specialize now in good Y. What does it mean in terms of welfare analysis, which is the fundamental thing we want to do with every economic model? We need to have the evaluation of policies, evaluation of counterfactual scenario. So what does it mean? In country A, we produce good X, which means that the relative wage, the real wage of workers in country A expressed in units of good X will be what we have computed before, would be equal to 1. The same with the relative wage of workers in country B expressed in the units of the second good Y. It will be also the same. It will not change. Why? Because the country B is still producing a good Y in the new equilibrium. Is the country A producing the goods Y in the trade equilibrium? No, it is not. The same for good X and country B. So good X is not produced in country B. There's full specialization according to the comparative advantage principle. But we know something about the new relative wages in the new economy after opening for trade. We know that the relative wages, the equilibrium, prices, not wages, prices. We know that the relative prices of both goods on the market will be equal to 0.6. And what is important here is that this number is in between those two numbers we had. Okay, it's not important for no worries. We simply assume that the equilibrium ratio of prices of both goods is equal to 0.6. So how can we compute for country A workers the wage, the real wage expressed in the units of goods Y? How can we do it? Well, we can do it by knowing that the real wage expressed in good X is given, and using the equilibrium price, the equilibrium price ratio that comes from the new trade equilibrium. And this will give us exactly what we need, all right? So we have 1 times 0.6, and we know that the real wage in country A expressed in the units of good Y is going to be equal to 0.6, all right? But we know that good Y is produced in country B and it's traded, it's exchanged to country A for goods X, okay? Well, the same we can do for country B. For country B, the thing that we don't know is W over PX, since the good X is not produced anymore in country B. So what we can do now is simply compute this we know, all right? Maybe I will simply delete this. All right, let's do it like this. Times 1 over the ratio of prices that we have out there. It's Py over Px. And we simply compute this equal to 0.33, which is 1 over 3, times 10 over 6. Yeah, for now. All right. And this is equal to 5 over 9. And this is something very close to 0.55, right? So these are the new real wages expressed in the goods that are not produced in both countries. The goods that are traded. Both good Y is imported to country A and good X is imported to country B. And now let's compare the welfare of individuals in both countries when those countries open to trade. And let's compare those 4 numbers we have out there. So we have 0.55 here, all right? And we have 0.6 here. And let's compare this situation to the autarky situation, which was here. So we see that the real wages in terms of goods in which are produced in both countries, they did not change, but the real wages expressed in the traded goods, so that the goods that are not produced in both countries, they increased. Why? Because the global production possibility frontier is now larger due to the fact that each of the countries specializes in the good in which it has comparative advantage. So in fact, there is a larger supply of goods in the total economy, as we have in our initial example of computers and bananas in the US and Colombia. This means there are more goods out there and the prices are relatively lower. And as you can see, in both countries, all the individuals in both countries are better off in the situation of international trade comparing to the situation of autarky, that is no international trade. And what is important, this is true even though country A has absolute advantage in both goods, in producing good X and good Y. So country A is more efficient in producing both goods. It's a developed country, while country B can be treated as a developing country. You see that even though this is the case, both countries are winning from international trade. Even the less efficient country in terms of both producing both goods. And hopefully this convinces you about the power, the strength of the notion of comparative advantage and the importance of international trade, the gains from international trade due to the fact that countries specialize in those goods in which they are relatively more productive. All right. So this is the end of the Ricardian trade model. I think one of four for today. Let's now move to another model, which is the specific factors model. So this model was developed by one of the most famous economists of the 20th century, Paul Samuelson, who is called the father of modern economics. The guy simply introduced mathematics into economics in the early 1950s and 1960s. All right, and he was awarded Nobel Prize in economic sciences, one of the most influential economists that lived in the 20th century. All right, so this economist Paul Samuelson came up with a model of international trade that motivates international trade in a situation in which there are two countries, there are two goods, and let's call those two goods, I don't know, clothes and food, and there are three factors of production, comparing to one factor of production in the Ricardian model. It was only labor, as you remember. We had only labor in the Ricardian trade model. Now we are going to have three factors of production. Two of those factors of production, that is capital and land, are going to be specific and used only in the production of one good. So we assume that clothes is produced using capital and labor, and capital can be used only to produce clothes. And food, the second good, and the second sector can be produced using land and labor, and land is the specific factor for producing food. Labor, on the other hand, the third factor of production, is a mobile factor. So you can see that we use labor to produce in both sectors. So in fact, the labor can move across sectors according to the marginal productivity of labor. All right. What is important in terms of this marginal productivity of labor and this assumption of the structure of the production function in the economy is that the production function of clothes, C, and the food, F, has two factors, one specific factor, either capital or land, and one mobile factor, labor. And we assume that, of course, the production function in both sectors is increasing in both factors, but there are decreasing marginal productivity of labor is in both sectors. What does it mean? It simply means that the more labor you put into the production of either of the goods, the relatively less productive it is. I hope that you are familiar with the notion of decreasing marginal productivity. Formally speaking, this means that the second derivative of the production function with respect to L in both cases is negative. Okay, so we have two production functions in our economy, one for clothes, one for food, and we know that the mobile factor has to sum up into a exogenously given supply of labor that is available in the country. But this labor can be divided into two sectors in a way that this supply equation is fulfilled. All right. So now we are ahead of describing a quite a complex graph. So, and in fact, this is the whole explanation of the specific factors model. Therefore, what I suggest here is that we will do it step by step using the graphical device, which is one of the most advanced ones that I have out there, MS Paint. Okay, let's go. So we have to describe the allocation of resources in the economy across the two sectors. All right. What resources do we have? We have two specific factors, which we don't care for a moment, and we have two factors that are, and we have one factor that is mobile, which is labor in sector. You know what? I'll change to black so that I don't kill myself with different crazy colors. Labor in sector C. I'm just checking whether, yeah, okay, whether I have good access labeling. So we have labor in sector clothes sector and labor in the food sector. And we know that the total supply of labor, capital L, is given. So what we have is a very simple supply equation that determines what are the possible combinations of labor in both sectors. This is a 45-degree line, or let's say minus 45-degree line, which tell us in every allocation, every point on this line tells us what is the allocation of labor between clothes and food sector. Okay, and it has to be a straight line because as we see it over here, this equation is in fact a straight line, LC equal to minus LF plus L, right? And this is exactly what we have here. This is capital L here. This is minus 1, the slope of the curve, and this is exactly the resource constraint in terms of labor. Very good. So now let's try to describe the production process in the sector of clothes. Once again, I will check. No, I don't have to check it. So now we want to describe the production process in the sector of clothes as a function of labor that is employed in this sector. So Q will be the total production in the sector, and LC is the amount of labor that is employed in this sector. So what do we know about the production function? So now we are going to plot the first function here. What we know is that Q, of course, is an increasing function of L, but since there are decreasing marginal productivities of labor, this decrease is going to be lower as long as we go further with employing labor, which means that the production function of labor is going to be a concave line, a strictly concave line, something like this. All right, this means that there are decreasing marginal productivities of labor in this sector. Okay, hope that everyone agrees what's happening here. So we have the production function in the first sector. What about the second sector? Well, we know that the production function looks quite more or less the same. So the only thing that I have to do right now is simply to get rid of this and change the labels to the production in the food sector. All right, this is labor in the second sector. Okay, so we are almost ready to be able to derive our production possibility frontier. That is the possibility, so the combinations of clothes and goods that can be produced in this economy, assuming the technology of production that we have here and here, and assuming a fixed supply of labor in both countries. So now we will do a bit of magic. So what we will do is we will draw a new graph that is going to be the graph, the function of the production possibility frontier, which is simply QC. Is it correct? No, it is not. We need QC here. Correct. And we need QF here. This. We want to compute, to draw the production possibility frontier, which is the combination of the goods that we can produce in the economy. As you remember, in the Ricardian model, the production possibility frontier was very simple. It was a straight line because the technology was linear. Now it is not the case. We have decreasing marginal productivities of labor in both sectors, which means that we cannot we will have a different shape of the production possibility frontier. All right. So in order to be able to draw it, all right, let me put it over here. We will do a bit of magic, which is possible in Paint and is not possible in the whiteboard, for example. All right. So we will take this graph first of all, and we will flip it, rotate it right by 90 degrees, and we will put it here. Okay. We will put it here so that the axes correspond, as you can see. Okay. I hope that you still believe that there is this part of the. I know what, I can do it better. I can do it better. I can do it like this. Okay. Right. Okay. So we have the same axis here, which is QC. All right. Let me just put it once again. It's QC. Then we will take the second graph, the first graph that we drew, and we will rotate it by 180 degrees. Once again, having a situation in which the axis corresponds. So now here we have the labor in the clothes sector. Everything is okay. I'll see. And we take our third graph, and now this is going to be totally insane because we are going to flip the graph horizontally. Yeah, now we have a brain damage, all of us, but this is exactly what we need to do. And we put it just here so that all the axes are well corresponding to each other. I will just put the LF node over here. Okay, so we are ready now to draw our production possibility frontier for any allocation of labor across two sectors of the economy. For example, let's take one particular allocation. Let's say we take this allocation of labor in each of the sector. We know that this gives us this particular amount of labor in the food sector and this particular amount of labor in the clothes sector. Both of those numbers give us a particular number of goods that we can produce in both sectors, right? Hopefully you agree. So we have one potential point that can be produced. Now I'm lost. One potential point that we can produce in the economy. It's, for example, this one. Now let's take a different allocation of resources in the economy. For example, let's take this allocation so that we have that many labor in the first sector, that many labor in the second sector, so that we can draw a second production point. Okay, it's somewhere here. Okay. And now we have to draw also the third point, which I don't want to do here in this graph, because still you don't know what's the shape of the curve here. I will tell you, it's not a straight line as it was in the Ricardian model. Apparently, it's going to be a concave function. So if you do this for as many points as you want, okay, at least 3, you will see that now in the specific factors model, the production possibility frontier is a concave line. Why? Because there are decreasing marginal productivities of labor in both sectors, okay? And this is fundamental in this specific factors model because it will define new source of gains from international trade. So as a small summary of what we have for the moment about the specific factors model. In the Ricardian model, labor was the only factor of production, and the production possibility frontier was a straight line because the opportunity cost of clothes in terms of food was constant, or any two goods, good X, good Y, good computer, and good banana, it was constant, okay? Now it is not the case in the specific factors model. We have a different shape of the production possibility frontier. We have a concave curve, and this is due to the fact that we have those diminishing returns to labor in both sectors. This simply means, in microeconomic terms, that the marginal rate of technical substitution between both inputs in both sectors is not constant. It was constant in the Ricardian model, so that we had a straight line there. Now it is not constant, so that we have a concave line, as you could see on the graph. So now the specific factors model will tell us that the effects of trade are always distributive. International trade will shift the relative prices of the goods that are traded. And this is something which I will not explain, but it's good to know. Trade benefits the factor that is specific to the export sector of each country, but hurts the factor specific to the import competing sector. And so, for example, if the country is going to export clothes, all right, capital was the specific factor for the clothes sector. This factor will surely benefit from opening to trade, and vice versa. If the country is importing clothes, capital is going to be hurt in terms of remuneration for output. This is something that we are not interested for the moment in this particular lecture, because I just want to give you some very brief basics about the intuitions why international trade is profitable and beneficial for the countries. That is why, instead of talking about those distributive effects of international trade, let us talk about the aggregate effects of international trade. So what's the aggregate effect of opening up the economy into international trade? To do this, we need to introduce one more notation here. So apart from consumption in both consumption of both types of goods, apart from production of both types of goods, so production of clothes and production of food, we will also introduce consumption of those two goods in a particular country. Moreover, we will introduce prices, equilibrium prices of both goods in the country. So we now have 3 pairs of variables in our model: the quantities of production, the quantities of consumption, and the prices of both goods. And we will compare the situation in which a country is in autarky, so no trade, and a country in which is opened up to international trade. All right, just as we did with the Ricardian trade model in our simple numerical example. So in autarky, what happens? Well, necessarily, the situation is very simple. What you produce is what you consume. You cannot consume more than you produce. You cannot produce more than you consume. And this is true for both sectors, for clothes and for food. Of course, you don't have international trade. What you produce is exactly what you consume, whatever prices, okay? The end of the story in terms of no trade scenario. Now, what happens in the situation in which country opens up for international trade? Well, now consumption and production might differ. So you can consume more than you produce. How is it possible? Well, you just import more of this particular good which you want to consume more. As easy as this. The one thing has to be still maintained in this new trade equilibrium for a particular country. The budget constraint of the country has to be fulfilled. So the value of consumption on the left-hand side has to be equal to the value of production, which simply means that trade has to be balanced. Yeah, the value of, if we have this PF on the left-hand side, this would mean that the value of imports in food has to be exactly equal to the negative of to the value of exports of clothes. So the trade has to be balanced. Why? Well, because this is the only market in the economy that we analyze here, and in the equilibrium, the market has to be in the equilibrium, of course, and you cannot have more money from what you to consume from what you produce. All right. So hopefully this budget constraint is very simple. We can rearrange this budget constraint in a way that we express the difference in the in consumption and production of one of the goods, let's say the food, as a function of the difference in the production versus consumption in the second good, the clothes, multiplied by the relative prices of those goods. So what does it tell us? It simply means that if you want to have a positive value of the left-hand side, which means that you want to consume more food than you produce in the economy, what you necessarily need is to produce more clothes than you consume clothes, export them, and import more of the food, all right? So that we have this balance kept in the economy. And this simply means that imports of goods is equivalent to exports of clothes in terms of the value, right? Not the number of items, but the value of items. The number times the price level, right? So what is this? In fact, this is a very simple linear function of QF and QC, right? And this is the coefficient, or the negative of this ratio of prices is the coefficient of the straight budget line. This is exactly the line, the black line you can see here in the graph. What are we plotting here? This blue line is exactly the production possibility frontier that we derived in our long analysis of the first graph we had out there. And if you put as much effort in drawing those points, you can do it by hand in your notes. You will see that it's exactly a concave function over here. All right, fair enough. So we have this production possibility frontier, which is a concave function, and we have a budget constraint in the open economy, which is a straight line. And now let's compare those two economies, the no trade economy and the trade economy. First, let us focus on the no trade economy. Let us assume that point 2, which is here, represents production and consumption autarky. Two remarks. First of all, the point is, of course, on the production possibility frontier, because it is efficient to produce on the production possibility frontier. All right. Second, note here, production and consumption of each and every good are equal to each other. And this is what we know from our initial analysis. If you don't have trade, you have to consume as much of each good as you produce. Not more, not less. All right? So point 2 represents both production and consumption in the closed economy. Fantastic. Now, what happens in the open economy? Let's assume that production in the open economy is any other point on the production possibility frontier. Why? Because prices will change and there are different incentives to produce through the prices of both goods. So there will be an equilibrium ratio of prices which determines which of the production process is efficient. I hope that you had this on at your microeconomics class. You have the budget line, with a given slope of negative price ratio, and the efficient optimal combination of production of each of the two goods is exactly the touching point of this budget line with the concave production possibility frontier. We draw it in the same way, in this way, because we can. It can be any other point on the PPP with a different slope of the budget constraint. Okay, this is simply to give you an idea. So we know what's the production in the open economy. But what is the consumption in the open economy? And this is the interesting part of the model. So the consumption in the open economy can be any point on the budget line. Why? Because the only constraint that we have in the open economy is the budget constraint. We can trade one of the goods for another good as long as the value of trade, so value of imports of one good, is equal to the negative of value of exports of the other good. Sorry, it is equal to the negative of imports of the other good, which is equal to exports of the other good. Then we are okay. As long as the budget constraint is fulfilled, we are okay in the open economy, which means that even though the production in the open economy is 1 point, the consumption in the open economy can be any point on the budget line. Okay. So what does it mean? It means that there are necessarily some combinations of consumptions of good F and good C that lie in this rectangle, this blue rectangle you can see over here. And this rectangle is very important because this rectangle contains all the baskets of goods that dominate the initial equilibrium with no trade. So for example, if you consume this particular amount of goods, you consume more of both goods, which means that this consumption dominates the previous one, the no trade consumption. Conclusion: with trade, you have a possibility, but not necessity. Possibility that you can consume baskets that are dominating the no trade consumption bundles, which means trade can be beneficial for everyone. There is room for redistribution of goods that could make everyone better off, because every point on the budget line is achievable in the economy. You can redistribute goods and resources in the economy in such a way that you achieve this level of consumption, and this necessarily dominates the previous basket of consumption in autarky. All right. So the fundamental reason why trade potentially benefits a country is that it expands the economy's choice set. Previously, in the closed economy, the choice set was constrained to a point. Now the choice set of the economy is the whole line, the whole straight line of the budget constraint. And this is the benefit of international trade. Moreover, in the world in which you have decreasing marginal productivity of factors, which is the world in which you are living exactly, this necessarily means that there is a possibility of having a Pareto improvement in terms of the consumption of goods that you have due to international trade, comparing to a situation with no trade, which is a fantastic situation because it tells you 100% trade is good for welfare in the country. Now the question is it indeed good for the welfare in the country? The fact that everyone could gain from international trade, unfortunately, does not mean that everyone actually does gain from trade. In the real world, the presence of losers as well as winners from trade is one of the most important reasons why trade is not free. Of course, there is a distribution effect between the owners of different factors of production in this specific factor model. This is the point that we skipped and we introduced it very briefly. This is this part of the slide. There are factors that benefit from international trade, but there are also factors that are hurt, that are losing from international trade. Those that have to compete in import-intensive sectors. This simply means that if you are an owner of a factor that is facing import competition, you are in a relatively bad spot. On the other hand, if you are an owner of a factor, production factor that is active in the export sector, then you are the winner. There is a distributive effect of international trade, which necessarily has to be the case in the world in which there are many factors and different technologies of production. The bottom line here is that whatever the distribution of the gains and losses from international trade is, the sum of those gains and losses in total, in the economy as a total, can be larger in terms of trade than in a situation without international trade. It is a semi-positive outcome of our modeling analysis over here. A bit of bittersweet, because we know that there are going to be winners from trade and there are necessarily going to be losers from international trade, right? And the only thing that we can say here is that if there exists a redistribution of goods that is, I wouldn't say to some extent solidar, let's say, in a way that there is no, you can make those, you can compensate the losers in such a way that everyone will be better off. But it's not necessarily the case, and in general, it is not the case. That is why trade is not free all over the world, right? So with this, we finish up with the second model. So to have a very short and brief summary of this first part of the lecture. So we started with the Ricardian trade model, in which the main concept is the comparative advantage. So you produce and export those goods in which you are relatively more productive comparing to producing other goods when you are in the international goods market, okay? This means that those goods that you produce are those in which you are relatively more productive. You have comparative advantage, not absolutely more productive. Okay, this has nothing to do with the absolute advantage. And we saw in our numerical example that this brings gains from trade. In the specific factors model, the concept here is that there are more factors of production. Some of them are specific for sectors. Some of them are mobile across sectors. And the production function has decreasing marginal gains, marginal benefits. Okay, and this brings you a situation in which the production possibility frontier is a concave line comparing to a straight line in the Ricardian model. And this brings you a different source of gains from trade. The fact that trade gives you a larger possibility set of consuming goods, which is not actually exactly equal to what you produce. So you can consume a different combination of goods than what you produce due to the fact that you exchange some goods for other goods, as long as you fulfill your budget constraint. So we have a break right now, and hopefully I see you, or you see me, in fact, in the second part of the video.